Hello, geometers. Here is a problem that you might see when you're talking about lines being parallel or perpendicular in terms of looking at their slopes or their equations. I'm given some points that are on my line. And in this case, it just says segment, but it could have said line. And so segment AB has these two endpoints. Segment CD has these two endpoints. But you notice that this one is not complete. So we're basically finding out what x would have to be for segment AB to be perpendicular to the segment with C and D. So the first thing I'm going to do is I'm going to find the slope of AB. The slope of AB, and there's not really a symbol that means that, so I'm going to write it out, remember this is my formula. The rise over the run is the difference between the y's over the difference between the x's. Sometimes that's called the change in y over change in x. It can even be written like this, with the delta symbol. Looks like a triangle. That means the change between some numbers. Okay, so I'm going to subtract my y's, and I'm going to subtract -7 minus -4. The order doesn't matter as long as you're consistent. -7 minus -4. What I mean by consistent is because I started for this side for the y's, I need to start on that side for that same point for the x's as well. So I wouldn't do -7 minus -4 and then start here for the x's. I have to start with the same point that I started with for the y's. So -3 minus -1. So that's -7 plus 4, -3 plus 1, -3 over -2, or 3/2. A negative divided by a negative is a positive. So that's the slope of AB. If I want CD to be perpendicular to AB, it doesn't need to have the same slope. Same slope means parallel. It needs to have opposite reciprocal slope. So in other words, I need the slope of CD to be -2/3. Opposite reciprocal. I flipped it upside down. Reciprocal means you take a fraction and turn it on its head. And I changed the sign. Okay, so that needs to be my answer when I do the slope of CD. How do we do the slope of CD? We subtract the y's, 6 minus x. So on top, 6 minus x. And then we subtract the x's. This is a different x from that one. Maybe I should have used a different variable. -2 minus 4. Okay, so here's my equation. When I do 6 minus x over -2 minus 4, I have to get this answer. So that's going to help me find what this x value here, this variable, has to be. So let's see. Let's simplify that. I've got 6 minus x equals -2 minus 4 is -6. And again, I'm going to write it over here. That has to be -2/3. Couple of ways I could solve this. Okay? I could sort of just do some number logic in my head and say, well, what over 6 simplifies to 2/3? And that would be 4/6. So I need this to give me 4 and write an equation and solve it for that. Or I can go ahead and solve this proportion the way I always solve proportions, which is cross multiplying. So let's come down here and do that. Notice it really doesn't matter where you put the negative for the -1 slope. This one has a positive slope, remember, so this one had to be negative. You could put it on top or you could put it on the bottom. Don't put it both places because just like we saw up here, a negative divided by a negative is actually a positive. So I put it on the top and I'm going to cross multiply. Let me get a different marker. I'm going to multiply 6 minus x times 3, and I'm going to multiply -6 times -2. Let's go ahead and do the -6 times -2, and I get 12 equals 3 times 6 minus x. I need to do it like this. It's 3 times all of 6 minus x, not just 3 times the 6. So I need to put it in parentheses and distribute. So that gives me 12 equals 18 minus 3x, and I get to solve this equation. And my answer is going to be x has to be 2. When x is 2, the slope will give me negative 2/3, and that will be perpendicular to segment AB. Hope that helped. See you next time.